Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah. Apa khabar semua? Sihat?
Sihat.
Sihat je.
Alright. Okay, good. Ramadan is coming next week. So get ready, yeah. Get ready. Practice for Ramadan. Okay. Today we are going to finish up the first derivative test. We have been discussing last class about the relationship between the f prime, the derivative, and the function. So based on that, we will come up with the first derivative test, and then we will be doing the second derivative test. That means we're going to look at the higher order derivative, mainly just the second, but we can do it up to the third, the fourth, and so on. But we will look at only second derivative, and then we will come up with the second derivative test. So hopefully I can finish this up. So that will cover, chapter number 9 and chapter number 10. So basically these two chapters. Now let's go back to what we learned on Monday. I think that is where we stopped, where you have the intervals, all right, for which the function, or not the function, for which the f prime or the derivative is positive, and there are intervals for which the y prime or the f prime is negative. And the separation point is the point where y prime is equal to 0, and that is what you call critical point. So the point where the y prime equal to 0, we call it critical point. So I think I did mention once or twice, but I didn't go into detail of it. So the point where y prime equal to 0, where should I write it? So now I'm going to make it more formal. So the point where y prime is equal to 0, that is what you call critical point. So now we set y prime equal to 0, and the value of x is x0, and then you will get the value of y will be y0. So the point where the y prime is equal to 0 would be x0, y0. Okay, so this point, you call it critical point. Why critical? Critical because after that point, where y prime equal to 0, the y prime will change. Okay, will change to either positive or negative. So that's why you call it critical point. Or in other words, more intuitive term, a turning point. A turning point. So that is where you make a turn. All right. If you look at the mountain, where you reach the peak, after you go up and then you have to go down. So that is a turning point. Or if you look at a valley, you go down, you reach the bottom, and then you go up again. So turning point. So either we can call it the critical point or turning point. So that critical point or turning point is the point where we'll separate the interval for which the y prime is positive and the y prime is negative. And we know over one interval, over one interval, the y prime is either positive for everywhere, or the y prime is negative everywhere. All right. So over one interval, you have only one pattern of behavior of the y prime. So let me just summarize the thing. So here, okay, number one, if y prime, okay, if f prime of x, I think sometimes we use y prime, sometimes we use f prime. So I write both. If y prime equal to f prime of x is positive for all x, okay, for all values of x in the interval, say a, b, okay, then what? Then you have the function f of x will be increasing, okay, increasing short form arrow up over the interval a, b. And if the y prime is negative for all x in a, b, then what? Then the function is decreasing. I forgot the word here, is decreasing. Arrow down over the interval a, b. Okay, so that is the observation. Okay, over one interval, the f prime will be positive for all x in that interval. We say fx or f increases over that interval. So let's go back to the graph. So you go back to the graph that we have drawn earlier. We know that the separating point or the critical point is function y equal to f of x. So you find y prime equal to f of x. And to get the critical point, what do we do? To get the critical point, we set y prime equal to 0. Then you will get x0, y0. So that is our critical point, the turning point. And therefore, based on that point, you break out into interval. So if I draw it like this, suppose the x0 will be somewhere here, right? And then what do you have? You have interval to the right, or to the left, I'm sorry, and one interval to the left. So here it's negative infinity to x0. And here you have what? x0 to infinity. So if you have interval, if you look at what you have here is this, if this is interval AB, all right? If this is interval AB, which is to the left of x0, in other words, this point now is B, yeah? Okay, x0 will be B. For example, you know, we go back to the consistent, to make the statement consistent. So if you have this interval AB, so if y prime, all right, is positive in that interval AB, then what? Then you say f is increasing in that interval. Okay. And if you have over this interval AB, y prime is negative, then what? Then the function is decreasing. Okay. All right. So let's go back to the graph that we draw earlier just to get a better idea. I think we understand that already. I just want to emphasize that one more time. So if you look at this graph here, all right, you have the y prime equal to 0. That point occur at x equal to 5. Okay, so x equal to 5, we find the value of y. Where is it? So that will be the point y. So that value 5 and the corresponding value of y, call it y0, correct? That will be what? That is the critical point. Okay, now we don't need that much, the value of y for now. Okay, what we need is more of the x. So here you have two intervals, all right? Based on the critical point, you have two intervals, negative infinity and 5. We already have that. The other interval is 5 infinity. So just look at the graph. You see here for the interval negative infinity 5, what can you say about the f prime? Is it positive or is it negative?
Positive.
Positive. So here we know, okay, graphically, if you relate back to what I said earlier, over an interval AB, okay, if f prime is positive at all x over that interval, then you say f increasing over that interval. So if you look at this interval here, you will see the f prime is positive everywhere, okay? You can start with the everywhere, the most negative value up to 0. You will see the slope will be positive. So the slope is positive at all x in the interval, okay? At all x in the interval, which is negative infinity 5. So therefore, what do we say? We say f prime increasing over that interval, negative infinity 5. Okay, all right. Now, if you look at the other side of the critical point, x equal to 5, the interval is 5 infinity. And what about the f prime over here? F prime over here is negative. Okay, I have already there, last time. So over in that interval, you see what? We see the y prime is negative for all x, everywhere. Okay, for all x in the interval. So what do we say? We say that the function is increasing over that interval. So we are talking about what? In an interval, the relationship between the y prime and y. If over that one interval, the y prime is increasing, what about the function? No, I'm sorry, y prime is positive, what about the function? The function is increasing. If the y prime is negative, what about the function? The function is decreasing. Okay, all right. So any question, any comment about this? All right. For now, what we want to do next is that we want to find, okay, using this observation or this relationship, we want to find the intervals, okay, the intervals for which the function is increasing and the function is decreasing. So let's look at an example. Suppose we have 5 equal to x squared. Okay, very simple function. I think this one we started with this function. So here, what we want to do here, you want to find, okay? You want to find the intervals for which the function is increasing, decreasing. So what do we do? So first thing that we need to do is, number one, you need to find the critical point, because that critical point will separate the intervals. Okay, where y prime is equal to 0, or you can use f prime equal to 0. So, either way you can do it. Now, what is y prime? Y prime equal to f prime of x, I now write x, equal to what? Equal to 2x. So to find the critical point, you set the value of y prime equal to 0. So therefore, 2x equal to 0 for critical point, because I already write the condition on the top. Now, what is the value of x? X equal to 0. Okay, so we can call that x0, okay, the critical point, 0. So we can find the value of y. Okay, what is the value of y at x equal to 0? Where do you substitute the x into? The original function or the derivative?
Original.
Original function.
The original function. Okay, so you want to find y, we substitute the x equal to 0. Okay, x0 equal to 0 into what? Into y. Okay, so very easy. Y equal to 0, that will be equal to 0. So call it y0. So now you have the critical point, or the turning point will be what? X0, y0.
Sure.
Yes.
The original function is x squared, right? Not
Yeah,
2x.
x squared. Because 0 squared, boleh tak? Put 0 squared, it's still 0. Okay?
Is it?
All right. Yeah. Thank you, because the y prime is 2x. We may confuse. So thank you. I should put the x squared. For other types of function, maybe we don't have to. Okay, so that is a critical point. All right, so that will break out into intervals. So you want to see it more clearly, you just put the number line here, x0 equal to 5, that will be the critical point. And then you break up into intervals. So how many intervals do I have? I have 2 intervals, one to the left, negative infinity to 5. And then you have another one to the right, negative 5 to infinity. Okay, so 2 intervals. So now if you look at the critical points, did we look at it last time? If you have 2 critical points, you have 3 intervals. If you have 4, you have 5. Did we cover on that one? Here, see, over this example last time, you have 3 intervals. Okay, so if you want to relate the number of intervals, normally the number of intervals is one more than the number of critical points. So if you have 2 critical points, okay, sometimes you have 2 critical points. You have 2 critical points. How many intervals do we have? 3. Okay, so you can go home, show that. So I think yeah. So now let's say, all right, for your homework, just to establish that thing. So go home, just do this. Suppose the critical point is 2, okay, x0, x1. So now draw the number line like this. And how many intervals? Should be 3, okay? So just draw. So here, go back to this diagram, to this example. I have 2 intervals. So now you want to determine, all right, over which interval the f prime is positive, over which interval the y prime is negative. And we know at that point, f prime is 0, all right? So now what you do, sometimes it's systematic that you make a table. So you table it up, all right? So here is the f prime. Oh no, not f prime, interval. Okay, the intervals here. So I have 2 interval negative infinity to 5. And then the other interval is 5 infinity. And then you look at the behavior of the f prime, and then what happened to f. All right. Okay, now we use this property. If the f prime is positive for all values of x, all right, in an interval, then the function is increasing. So from there, when you want to test whether the f is increasing over that interval or decreasing over that interval, we need only one test point. Because if it is true for all points, right? Then the function has property the y prime increasing or decreasing. So you need only one test point. Let's say the test point in an interval. So you need only one test point. And of course, that point, that value of x, input AB to test for f prime positive or negative. So that point must be in the interval. So if you go back to the interval negative infinity to 5, okay, give me 1 point. That interval. What is 1 point? Give me 1 point in that interval. Hello.
-3.
Negative 3. Okay, you can use negative 3. All right, negative 3. 1 point, negative 3. Give me 1 more point.
1.
0.
1, 0, 2. All right. So when you do this, normally we'll go for the one that is easy to compute. Okay. Now for this one, which one is the easiest to compute?
0.
0. So you can use other number. Okay, that's fine. But now, our criteria is you want to get the smallest number in that interval. So x equal to 0 in that interval. So test point x equal to 0, you'll see f prime. Okay, substitute into the f prime. So there will be what? There will be 2 times 0. So now first you need to know the f prime, whether it is positive or negative. 2 times 0. F prime is equal to 2 times 0. You get 0. Okay. Now 0, is it negative or is it positive? Betul ke ni? Wait. We have F prime. Is it right? Bukannya 5. What is our critical point? Mana saya dapat 5 ni? What is our critical point?
0.
0. Macam mana saya boleh buat 5? Anybody realize the mistake? Pelik ke? Because when we put 0, we got 0. You know, 0 is not positive or it's not negative. I mean, 0 can be positive lah. You have a bigger or equal to 0. But here we are looking at strict positive or strict negative. So that was not 5. How come I got 5? Ada orang perasan tak? Ada perasan tak lepas 5 ni? Kalau tidak habis ajaran sesat ni. Ini ajaran sesat. Mana boleh 5? Mana dapat 5 ya? Siapa tahu mana saya dapat 5 ni? Anybody can recall where did I get the 5? I don't know. What about you? Do you know?
Untuk tunjuk contoh kot, sir.
Dari graf kot, sir. Graf yang
Contoh,
kita
sir.
tunggu.
Itu contoh tadi lah. Contoh tadi.
previous graph.
Bukan yang ni. Yang ni patut lain. Aduh. Sorry. Okay, it's not 5. So now we look at the actual point. Okay. So actual point, we constant. Okay, potong balik. So critical point, 0 and 0. So critical point is y0, x0, y0 is equal to 0, 0. That's the right thing. Okay, yeah, that was the example. So I was using that example. Okay, thank you. So x0, y0 ni 0, 0. All right. So the intervals, okay, so forget about this because this belongs to the other example. So the interval would be what? From negative infinity to 0, and then 0 to positive infinity. Yeah, that's the thing. So now 0 is out. So 0 is out as a test point. So if I go back to the number line, it will be like this. Here 0, and then you got one interval to the left, one interval to the right, which I already listed there. So the critical point, okay, so here we have to make a correction. 0. So critical point, give me a critical point. 1 point is -3. Okay, give me one more, which is easier to compute.
Negative 0.5.
Negative 0.5 or -1. Okay, you use round number, it's not. Okay, -1. So you put -1 or -2. Okay, so the smallest one is -1. So what do you get? I get 2 times -1. That is equal to -2. So f prime is what? F prime is negative. Okay. Now f prime is negative. What about the function? The function is decreasing. Okay. So we know the interval on the left of 0 is decreasing. Okay. And at 0, the slope is 0. Y prime is 0. That's the critical point, or that's the turning point. Now for the other interval, take a test point. Okay, give me one test point. 0 is not included, all right?
1.
Okay. 1 lah. X equal to 1. I get f prime equal to 2 times 1. That is equal to 2, and that 2 is bigger than 0. So therefore, the f is increasing. So you look at the interval on the left, all right? The function is decreasing like this. And then to the interval on the right, the function is increasing. So now you know already, the general behavior of the function. So when you want to sketch the graph, okay, when you want to sketch the graph, the basis would be just the critical point. We need to locate critical point because everything will be related to the critical point. Okay, because it's increasing or decreasing, it starts from the critical point. So the critical point is 0, 0. So I draw it again, the graph. You have 0, 0 as the critical point. So that is the point 0, 0. So that is our point. Okay. And from the left, okay, on the left, negative infinity to x, the function is decreasing. Okay. So the function is decreasing. You will draw it like this. Okay. After that, what? Increasing. So that is the graph of x squared. So y squared, I'm sorry, the function y equal to x squared roughly look like this. So the only point that you need to determine, of course, would be this one, the critical point. All right. Don't worry about other points because we just want to sketch. All right. We are not drawing it. Just sketch. Okay. Any question? So here, okay, you will see the graph, and we know the intervals. All right. I give you another example. So you want, I would like you to do another example. Let's say example number 2. I want you to do it. Okay. I give you also quadratic function. Let's say y equal to negative 3x squared plus berapa? Plus 12. Okay, now I want you to find or to repeat the first example. Okay, that means find the interval for which the function is increasing and decreasing. Okay, do it now. All right, first you need to find the critical point. Okay, that means first, of course, you have to take the derivative. And then for a critical point, you set that derivative equal to 0. Okay, what is the point that you get where the y prime is equal to 0? What is the value of x?
Negative 6x.
That's the y prime. Okay. The critical point. What is the value of x? So you get x. You get x equal to 0. Now you find the value of y. All right, the value of y, so that we will have the critical point proper. So what is the value of y when x equal to 0?
12.
12. So critical point is 0, 12.
0, 12.
So you know already that will be the turning point. Okay. So based on that value of x, you break out into intervals. So again, interval is based on the critical point. So you have what? You have 2 intervals. Okay. Table up the interval and then do the test point, and then see how the f prime and the f relate. Okay, finish it up. Okay, got it. All right. So you table the point, okay? You table the points, and then you look at y prime, and then y. Okay, done. All right, I will do together. So number one, okay, you need to find the critical point. Okay, critical point or points, because it can be more than one. That means y prime is equal to 0. So you get y prime is equal to negative 6x. And then for critical point, or you know, point, you set the negative 6x equal to 0. That means x equal to 0. X equal to 0. Now what y? To find y, all right, then substitute x equal to 0, not into y prime, okay, because you want to find the critical point. Substitute into y, right? So y equal to negative 3, 0 squared plus 12. So that is equal to 12. So the critical point is what? Is 0, 12. Critical point is 0, 12. So that is x0, y0. You don't have to write x0, y0 lah, because now you have 0 and 12. So there are two intervals. One is to the left, and then you here get y prime and y. Okay, so first interval is what? Negative infinity, 0. Second interval, 0, infinity. Again here, you test point, x equal to 1. Now when x equal to 1, what is y prime? Y prime is negative 3, 1 squared. I'm sorry, 1 squared. Negative, I see. So you need to do some practice, you know. Sometimes you may do error. So y prime equal to negative 6 times 1, that is equal to negative 6, and that is less than 0. What about the function?
Decreasing.
Increasing or decreasing?
Decreasing.
Decreasing. So the f decreasing. Okay. Now x equal to, oh ini silap ni. Ini bukan 1. Now can I test 1 here? From the interval negative infinity to 0.
Negative 1.
Negative 1. Apa saya tak beritahu saya? Malam tadi saya tidur lambat. Saya tengok Liverpool kalah. Dah lah Liverpool kalah. You know, tidur lambat. So pening di kepala ni. So, you know, kalau Liverpool menang, bolehlah tu sikit. Ini kalah pula. Aduh, penat lah. So, I'm sorry I may make a few mistakes. Okay, but you make the correction. Bagi tahulah, jangan main diam ya. Okay, ini silap ni. Now, the interval is negative infinity to 0. It shouldn't be 1. It should be 1. It should be negative
1.
So, kalau saya buat silap, cakaplah cepat. You know, janganlah tunggu saya. Dah. Okey balik. Tadi dia off sekejap. Okay. Can you see the screen now? Nampak boleh? Okay. So now we will.
Yes,
Okay, good. Because I was disconnected not from the internet but from Zoom. So here you have x equal to negative 1. Okay, negative 1. You got negative 6. Negative 6 is negative 6 multiplied by negative 1. That is equal to 6, and that would be positive. Okay, 6, positive. So what about the function? The function is increasing. All right. Now the other interval, we use x equal to 1, y prime equal to -6 multiplied by 1, that is equal to -6. That is negative, less than 0. F prime, or not f prime, the function f would be what? Would be decreasing. So you'll see here, on the left, it is increasing. On the right, it is decreasing. So you can now already, intuitively imagine how does the line look like, or the curve look like. So I draw on the same graph, okay? And I draw with another color. So the critical point is somewhere here, 0, 12. So that is our critical point. Now the interval from -infinity to 0, the function is increasing. Okay, so from here, it is increasing. On the left, it is going up like that. And then after that, what? We go down. Okay, so it's like a mountain. Okay, you go up, you go down. The example y equal to x squared is like a valley. So let us draw it nicely. And the turning point, okay, is where the derivative will change sign. So I draw it with another color. Let's see, I draw it here, blue. So it's here the critical point. So that is the function increasing, decreasing. Okay, so that is y equal to -3x squared plus 12.
Yes,
So that is the curve. Is it? So that is the curve. So the function will look like this. All right. Next, if you look at the critical point, there is something that is special about the critical points. The critical point number 1 for the function x squared, this critical point, the curve is going down and going up. And then for the second example, the critical point is 12, 0, 12. The curve is going up, going down. Like I said, one is a mountain, the other is a valley. Okay, so these points, we call it the critical point, can be a relative maximum or it can be a minimum. Sometimes we use relative, but for our purpose, normally the function we look at will be not so big, not so high power, and that you have more than one maximum or more than one minimum. So the word relative indicate that you may have two minimum. All right, and the other two minimum means relative minimum, because you may have another minimum that is what? That is smaller or lower than the first minimum. So you call it relative. But for us, the relative is the only one that you have. So we just call it minimum or maximum. All right. So the maximum or the critical point can be a maximum or it can be a minimum. As we can observe here, y equal to x squared, that function has a minimum at 0, 0, which is the critical point. And the other function, okay, the other function, y equal to -3x squared plus 12, that has a maximum. Okay, because that is the highest value. Now, what is the criteria for a maximum or minimum? So this is the criteria of maximum minimum for the critical point. So what we will do, based on what we have learned, we extend a little bit more. So this is what you call the first derivative test. All right. So first derivative test, you consider a function y equal to f of x. All right. And of course, you get the y prime equal to f prime of x. And number 1, you get the critical point. Okay, critical point where y prime equal to 0, say at x0, y0. So based on that critical point x0, y0, you have intervals. Okay, now if the interval on the left We call it ax0. If the interval here, left interval, okay? Interval on the left of what? X0. If for the interval ax0, the f prime of x is what? Is positive, okay? And you know the function is increasing, all right? And then you look at the other interval on the right, x0, call it up to b. This is the right of x0, okay? And f prime of x is negative, and we know that the function is decreasing. So do you have a maximum or do you have a minimum at x0, y0? The function is increasing from the left and then go down.
Maximum.
Huh? Maximum kan? So number 3, if you have this property, all right, so you have what? F of x has a, okay, you can say relative or you don't have to say relative, that's fine. Relative maximum at x0, y0. Okay, now you don't have to remember this. This is just to summarize. You don't have to remember. What you do is you just draw the graph like what we did here. Okay, you draw the graph, you find the intervals where it is increasing or decreasing, and then you draw the graph, you sketch the curve, okay, and then you conclude. All right, that means will be what? Will be increasing. Will be maximum. So the criteria for maximum is what? The interval on the left, you have the function increasing. That means f prime is positive, no? And then the interval on the right, the f prime is negative, function is decreasing. So you have a maximum. Now for minimum, everything will work out the other way around. So you have to the left of x0, f prime is negative. I put in red here. And the function is decreasing over the interval on the left. And if the interval on the right, f prime is positive, the function is increasing. So now what do we have? We have a minimum, okay? Relative minimum at the x0, y0. So you have to repeat this. If there are more than one critical point, okay, you have to repeat the test for each critical point. So extension here, if you have more than one critical point, okay, you have more than one, that means 2 or more lah. Well, more than one critical point, okay, you have to just do it for every test, okay, repeat for each critical point. So for each critical point, you know, you have the interval on the left, interval on the right. The second critical point, you have interval on the left, interval on the right. Okay, because one critical point, there are 2 intervals, one on the right, one on the left. Okay, all right. So let us talk about another example, you know, where there are 2 critical points. So I draw the graph earlier. I think I draw a graph, a cubic function, you know. Will look something like this. Where was it? That's how they work. Okay, yeah. Okay, so here you have 2 critical points. Y prime equal to 0, and x equal to -10, and x equal to 5. Okay, so first you consider the first critical point, x equal to -10. There will be what? There will be 2 intervals, one to the left, one to the right. Okay, and similarly you do for -5. For 5, I'm sorry, 5, the second critical point, you have 1 interval to the left, all right? 1 interval to the right. Okay, now that interval you consider will be what? Will be bordered by the critical point. Okay, so if you look at this one, what is the interval? If you look at x equal to -10, to the left is easy, -10, negative infinity to -10. Now, what is the interval to the right? From where to where? Interval to the right. Did we do this last class? Oh, here we do that. Okay, what is the interval to the right of -10? Because here, okay, here there is another critical point. So from where to where? The interval to the right of -10.
-10, 5.
-10 to 5. So that is our second interval. Correct? And of course, there is another interval to the right where you have from 5 to infinity. So we know that already there are 3 intervals. Okay? Because we did it on Monday. But when you want to test a critical point, whether it's maximum or minimum, you need to look at the 2 intervals, to the right, to the left. So here that is the left interval, that is the right interval for x equal to -10. Now you look at the other critical point, where x equal to 5. So what are the intervals? What is the interval to the left? There will be no interval. There will be no other interval. The interval is already for the same curve. What is the interval to the left? Of x equal to 5. From where to where? The interval on the left.
-10 to 5.
-10, 5. So this one is the left now, because we are looking at x equal to 5. And what is the interval on the right? 5, infinity. So the interval in the middle here, -10 and 5, that would be what? That would be the right interval for the first point. And then for the second point, there will be what? There will be the left interval for the second point. Okay? So what you need for each of the critical point, you need to look at the 2 intervals, on the left, on the right. And some of the intervals are the same. Okay? Because it's on the same curve. Correct? Okay. Any question about this? Okay. So let's other question. Okay, let's consider another example. Okay, this one is the one that relate to what we have been doing just now. So I give you another function, the cubic function, and that, we will get 2 critical points. So when you got 2 critical points, that would be okay. Critical point, 2 critical points. I want to find that. I've got it. Where is it? Tunggu kejap. Nanti saya bagi main tab ni tadi, nanti susah juga tak berjumpa dengan apa tu, critical point tu. So I got to do it to get the function that is workable. Wait a minute. Ini dia. Alright. So let's consider this function here. Example number 2. You have y equal to 2x cubed, okay, minus 12x squared plus 5. Okay, now I want you to we want to find, okay, the intervals for for which the function is increasing, decreasing, and you want to find a maximum, minimum. Okay, all right. So number one, what you do here is, I think we have not made the conclusion yet, regarding the maximum, minimum. So we go back to this statement here. All right. So now you know already the intervals. So therefore, if I relate back to the two examples that we have here, okay, for this one, you see here the critical point is what? At 0, 12. Okay, and then to the left of the critical point 0, so this is the left interval, that is to the right. Okay, the function is increasing on the left interval, and then on the right interval the function is decreasing. So what can you say? So what? So the function has what?
Relative maximum point.
So it is going up from the left, going down. So relative maximum, or just maximum at 0, 12.
Yeah.
Okay, but you don't have to remember those things. You just look at the behavior, sketch the graph, conclude. Okay. Now look at the first example. You have the critical point was 0, 0. All right, and then on the left interval and the right interval, you see the function is decreasing from the left and then increasing to the right, on the right. So what can you say about the critical point? So what about the function? Does it have a maximum or minimum?
Minimum.
So the function has a relative, or you don't have to say relative, minimum at 0, 0.
0.
Okay, and that is of course shown by the graph. Okay, all right. So that is the first derivative test for maximum, minimum. So now if I have this graph or this function here, y prime is equal to what? 6x minus 24x. Okay, 6x squared, I'm sorry, 6x squared minus 24x. Now for critical point, we set that to 0. Okay, y prime equal to 0. So therefore, 6x squared minus 24x equal to 0. You factor out the x, you factor out 4. Okay, so you got 4x. No, not 4.
X square minus 4, sir.
X.
6x, sir.
So you factor out the 4. Is that right? You factor out the 4 x squared minus 4. Betul itu kan? X squared minus 4.
Sir.
Sir.
Yeah.
Bukan 4 tu, sir. 6 in bracket x square minus 4.
Minus 4. Yeah, that's right. Because 6 times 4 is 24. So here it should be 6. Betul lah, 6. Yeah, that's right. So here it should be 6. Okay. So the 6 you bring out to the right, be just 0. So that one, this one will cancel out. So what you get, x squared minus, here is 4x. Okay, x squared minus 4x. Okay, now that everything is correct. Betul tak? 6x squared minus 24x. So the x6 now is gone. So you have x squared minus 4x. So you factor out the x. I got x minus 4 equal to 0. So this is like a quadratic function. So there will be 2 roots, correct? Quadratic function, 2 roots. That means there will be 2 critical points. Number 1, you set x equal to 0. And then number 2, you set x minus 4 equal to 0, x equal to 4. So you got 2 points, x equal to 0, x equal to 4. So, of course, you want to find what is the value of y over here and the value of y over there. All right? Okay. So, I didn't find the y yet. So now, can you use your calculator, find y? First people from A to M. Find the value, senang je, tak payah. Find your x equal to 4. Okay, 0 senang sangat. because here that will be equal to 5. So the first critical point will be 0, 5. Okay, tak payah, I can do it. Okay, for the second one you need calculator because 4. Can somebody do it? Get the value? First one, tell me.
Sixty-three. Number 3.
Betul, 63. Everybody got 63? Okay, so second point is 463. So here, all right, if I just draw the number line for the x, you can see there are 2 intervals. No, 2 intervals, 2 critical points. 0, 4. Okay, and there will be 3 intervals. One from negative infinity to 0. Second, 0 to 4. And third, 4 to infinity. All right, so now let's check what is the behavior of the y prime and y, of course, for these intervals. Okay, all right. So tabulate the interval. So tabulate the interval, betul eh? 4 here, 4, 0, 5, 0, 4. Okay, so you have the intervals. Now, tabulate. I want you to tabulate the thing, put in a table, get a test point, get the value of the y prime, and conclude whether the function is increasing or decreasing. Okay, good now. I give you 3 minutes. Okay. All right. So, you tabulate, there are 3 intervals, okay, 3 intervals. So just check whether you have a decreasing or decreasing function for each of the intervals. All right, you done? Okay, first interval, the negative infinity to 0. Okay, what is the test point you do? Okay, I summarize the intervals. So first interval is negative infinity to 0. Okay. Now test point. What did you do? What did you take? X equal to what? Negative 1. Yeah? Okay. X equal to negative 1. What is y prime? Or f prime? Y prime equals what? Okay. What?
30.
So you use the y prime. Okay. 6x minus 24x. So that will be the y prime. Okay. So y prime is 20. Is it 6x? Yeah, 6x. 6 times 1 minus, no, I'm sorry, negative 1, minus 24x, 24, 1. So what is it equal to? Negative 31, negative 30, right? Negative 6 minus, no, negative 1, no, I'm sorry, negative 1 squared, negative 1 squared. So it becomes 6, 6 minus 24, that is negative 18. Is that right? Negative.
Negative
30, sir.
multiply
30,
with
sir.
-1.
Huh? Yeah,
Negative
yeah, yeah.
34 multiply with -1.
Yeah, -1. So that become 30, yeah. 30. So 30 is positive. So what about the function? F or Y is increasing. Okay. Now we do for the second interval from 0 to 4. We take the value x equal to 1. Okay. So y prime equal to 6 multiplied by -1 squared minus 24, 1. So that is equal to 6 minus 24, that is -18. Betul tak? -18. So
Betul,
that
sir.
is less than 0. So the function is decreasing. Okay. And then you look at the third interval for up to infinity. Okay, I take 5, or you can take 10. Okay, or you take whatever you want. So you use 5. Then y prime is equal to 6 multiplied by 5 squared. Okay, minus 24, 5. Okay, berapa ni?
30.
30. So you got 30, that is positive. So the function is increasing. So you see here, the curve is increasing, decreasing, and then what? And then increase again. Okay, so let's see. At which point you have a maximum, which point you have a minimum. So since, I have two critical points, we draw it bigger. Because one is, or somewhere near the origin. The other point is quite high up there. So let's get a bigger graph. So I think that will be okay. X, Y. And then betul kita ni. Kejap Kita buat dulu. 0, 4. I think I'm going to do it all the way lower because I don't have a negative value.
So tadi critical point ada miscalculate.
Itulah saya rasa macam pelik je value ni. Go back to the table. Okay, you have the y prime equal to 6x squared minus 24x. That's correct already, kan? Okay, mana yang
So bukan yang ni, yang critical point.
Oh, critical point silap. Okay, critical point silap apa benda?
Tadi tu 0,5 dengan 4 negative 59.
So silap dia dekat mana? Yang 4 ni ya?
63 tu. Patutnya negative 59.
Betul? Betul?
Betul.
Tadi apa saya cakap? Apa saya cakap? Betul. Ada somebody give me 63, nobody object. So I didn't calculate. So I thought that is true. So next time, kalau ada silap, bagi tahu cepat lah. Itulah saya dulu tengok. Lain macam je, increasing, decreasing je. Okay. So now I think may look better lah. So you got 4, negative 59. Okay, so that is the point. So the point is far down there, negative. So you will draw the graph. So I have to draw the graph a little bit up. So be somewhere here. So 0, that is x, y. So first point is 0, 5. So 0, 5 is somewhere here. Somewhere here. And then you have the other point is 4, negative. So 0, 4, 1, 2, 3, 4, 4, somewhere here, 4. That 59 is somewhere here. Okay. So here you have the curve going up from the left, from negative infinity 0 going up. After that, going down. Okay, and go up. Itu boleh make sense. So here you have, you know, this one, that will be the maximum. So it's going up, All right, going up from there, going up, and then going down, and you go down like that. So now I have to make adjustment, but cornering tak cukup. So you know, anyway, this is just to sketch, right? You don't have to worry about the scaling, as long as we have the enough space for the curve to turn. All right, so that is the negative 59. Then go up again. So that is y equal to 2x cubed minus 12x squared plus 5. So here the curve is going up, going down, going up. All right, so consistent with the tabulation that you have. So you can see here for the first critical point 0.5, the curve, the interval on the left increasing, and then table on the right decreasing. So what you can say, this one has a maximum. And then for the second point, critical point 4, negative 59, interval on the left, 0 to 4 is decreasing, interval to the right is increasing. So what? Minimum here. Okay, so for this function, you can observe, okay, the behavior of this function here. So you can say from this 2, you have a maximum, and then for that 2, you have a minimum. All right, so you can say here the function, but for first derivative test, sometimes it's good that you sketch the graph, okay, so that you know, confirm that is the right thing. So you can say that the function has a relative maximum at 0, 4, and relative, or you don't have to do that, minimum at 4, negative 59. Okay, all right. So that is the behavior of the f prime, and
It should be at 0.5, right?
0.5. Okay, 0.5. Okay, so it should be 0.5. Okay, so that is the relationship between the y prime and the y, and we call that first derivative test. So let's see whether is there any question that you can do. So let's go to the book. Let's go to the book and see. Let's look at 10.1. I think that is about 10.1. Let us do a few questions. Okay. So for homework, I'll give you 10.1. Okay, 10.1. Do number. We should start with some simple function. Okay, do number 15, 16. Okay, all these are the quadratic function. Okay, and then they give you cubic function. Okay, and then do 21, 22. Okay, all these are the quadratic. All right, and then we do the cubic, some cubic function. So do number 7, number 8, and number 17. Number 17, and then number 25. So we do only the quadratic and the cubic. Okay, don't worry about higher order function. So this is the cubic. So you have two here. You have two critical points, right? For the quadratic, you have only one critical point. Okay. Now I should have given you some exercises, for the application on Monday. So I'll give you now. This is the questions on chapter 9. You know, the application 9.9. I think 9.9. I have not given you a question yet. Okay, so 9.5. I think 9.5. I haven't given you, but I just if I have given you, that's fine. So 43, 48, and then 9.9. I have not given you. I think 3, 5, 6, 22, 28. So that is 9.9. That's 9.5. So okay. All right. Any question? So we are done with the first derivative test. So now we go back to 9.9. We want to look at the higher order derivative. That means we do the second derivative, third derivative, or fourth derivative. So the function y equal to f of x, when you take the derivative is the function. Okay. Now, when the derivative is the function, you can differentiate the derivative. Okay, and continue to take the derivative. So the derivative of the derivative is called the second derivative. So this is 9.8. So you consider a function y equal to f of x. Right? You take the derivative or you differentiate y of x, take the derivative of y. What do I get? I get y prime equal to f prime of x. Okay, now y prime is a function of x. So we can differentiate y prime. Okay, you differentiate y prime. So you differentiate y prime, what do I get? I get y double prime. So here is called the second derivative. That means the second generation. Here is your parent. Okay? And here is you, the derivative. And second derivative is the grandchildren. It's your children, grandchildren for your parents. Okay? So second derivative. And then the y double prime is also a function. So what do? You differentiate it. Differentiate y double prime. So what do I get? I get y triple prime equal to f triple prime of x. So this is what you call the higher order derivative. We can continue to differentiate until you cannot differentiate anymore. Okay? Until you cannot do anymore. So you can take the 8th derivative, the 7th, or the 9th, the 10th, whatever, depending on the function, until you cannot. All right? But for us, okay, for our purpose, we'll do up to the second. Okay, so we do up to the second because that is the one that is relevant to us. Okay, all right. And all the rules of derivative apply. Okay, the rules that you learned earlier will be the same. Okay, we don't have any new rules. Same rules. So the cubic, not the cubic, the quotient rule, the power rule, product rule, everything will be applicable. So let's consider an example. So you look at 9.8. Okay. Say I have the following function. Y equal to 5x squared plus 13x minus 9. Okay. Differentiate the function. What do I get? I get y prime equal to dy dx equal to what? Equal to 10x plus 13. Now that's a function. Can I differentiate 10x plus 13? I still can. Okay. So you take derivative of y prime. So you got y double prime or d2y dx squared. Or you can write f double prime. Okay. But normally we write this notation. Let's now cannot write. Equal to what? Differentiate 10x plus 13. What do I get?
10.
10. Now, is 10 a function? Is it a function or is it not a function? Yo, is it
No.
equation?
No.
Siapa kata no? What function is that? Does anybody remember?
Constant.
Oh,
Constant function
constant.
is still a function.
That's a function. Yes. Yes.
Okay, so you can take the y triple prime derivative of n. What do you get? You get 0. Okay, differentiate a constant, you get 0. So that's the end. Cukup lah tu. If you constant differentiate 0, you got 0, 0, 0 sampai kiamat pun 0, 0 tak habis. Okay, so you stop there. Alright, so you continue to do the derivative until you cannot do anymore. Or if you do, you keep on repeating the same thing. So that's it. So you can get up to triple prime. Okay, all right. Now let's do another example. Okay, let's say I have y equal to 3.5. Kita bagi whole number lah, senang sikit nak multiply. Say 8x to the power of -4 minus 15x to the power of b plus 60. Okay, now take the derivative of this function. So first derivative, y prime equal to f prime. No, I just do this because I want to write the different notation. But you don't have to, okay? You just write y prime. Go to dy dx equals what? What is the first derivative? Tell me.
32x.
-32x.
32x to the power of
-5.
-5
minus 45
minus 45x squared.
x squared. Now that's a function. You take the second derivative, okay? Or you call it d2 dy dx squared, f double prime. Now what is it equal to? You got -32 times -5.
160.
Berapa dapat?
160.
160.
160.
X to the power of -6 minus 90x. Still a function. So you continue differentiate. Okay? For this function here, to what degree of derivative can we do? What degree? What is the highest derivative can we do? Huh? What is the highest? You take the third derivative, you take the fourth derivative. Okay, what is the highest? Will there be the end of the story?
No.
There will be no ending because it's a negative. You continue to be negative, -7, -8, -9. You do it until you get all. You still can do the derivative. Okay. So for this function here, you can continue to do. There is no stopping. But we do up to here lah. All right. Okay. Any question? So that is the second derivative. So what I want you to do, you go to 9.8. Okay, 9.8. I would like you just to practice. Okay, practice doing the second derivative. I think the highest. Okay, the highest that I would like you to do, maybe up to the third derivative. Don't do more than that. So if you look at the book, they ask you to find the second derivative, and then they ask you to find the second derivative. So we do for each question up to the third derivative, if possible. Okay. All right. So just for your practice. So 9.8, I would like you to do some questions which are do number 1, and then number 3, and then number 6. Okay. And then there'll be a few more. Do number 14, and then do number. You want to see, the application of the different rules. Let's say do number 20, number 24. Okay, number 24, you use the quotient rule. All right. Yang this one, try, okay? Try to do up to the second, because if it is a quotient rule, involves so many terms, tak payah apa lah. Number 24, get the first derivative. If possible, you can try the second. All right. If it is too long terms, you have to do so much things, don't have to do it. So I give you 1, 3, 6, and then 14, 24, 14 lagi je. And then did I give you 14? Okay, another one will be 16. Okay, 16. All right, so do up to the third derivative. So you have to do, if they ask you to do the third derivative, you have to do the second derivative, because otherwise how can you do the third derivative right away? All right, okay, good. So I think I will stop here. Now, next class, next week, we are going to do the second derivative test. So you go to chapter number 10, all right? We do the second derivative test. Now, second derivative test is more compact. It's shorter, and it's more straightforward to test for maximum and minimum. So you call that second derivative test. We use the second derivative to test whether the function has a maximum or minimum. It's easier than the first derivative. But the first derivative test is good, for us to get the intuition, okay, for us to get the picture of how maximum, minimum, what does it mean? So that is what we're going to do next week. We'll get the second derivative test. All right. Now it's already six weeks, right? The week number 6. Today, Wednesday. This week is already week number 6. So I want to have a quiz. All right. So our quiz will be in week number 7 next week. That will be on Wednesday. Okay, Wednesday on the 14th. Today is the 7th. So on the 14th of April. So you have first quiz. So get ready. We have the first quiz in the class. So probably about 40 minutes. It will not be many questions. Normally quiz, if you simple question, so that will be next week. Okay. All right. So now, when you have the quiz, I want to make sure. Okay, I want you to turn on your video. Okay. So when you do the quiz, so that I can check you, at least I can see your picture. So for the quiz, you turn on the video. Okay, like this. You turn on the video so that I can see. You see myself. Okay, I turn on my video, and there were a few students who turned on video. Mana pergi budak-budak tu? I thought there was. So for the quiz, or for the test, I would like you to turn on the video so that I can invigilate better. Okay? So turn the video. So you practice lah, okay? Practice. If you do the Zoom meeting, turn on the video so that when I click your name, I can see you. Okay? All right. So I will remind you again next time. So please, all right, for the quiz or for the test, I would like everybody to turn on the video so that I can see you. I can invigilate better lah. Mana? I thought there were a few students who turn on the video earlier. Okay, tak apa. So make sure, okay, on Monday class next week, we put a trial. Okay, you turn on your video so that I can see how it works. And for the quiz, I want to see the video on. Okay, all right. Anything? Any question? Anything? No. All right. Yes.
What topic will be covered in the quiz?
The topic covered will be the topic until Monday next week. Okay, up to Monday on the 12th. Okay, so what you will learn today and then what we learn on Monday next week will be included in the quiz. All right, Monday on the 12th. Okay. So now you have the quiz on the week number apa? Week number 6 and number 7. Week number 7 kan? So
Yes.
you have now week 7 the quiz. So the test, okay, the test will follow soon because you have 10 week number 10. After week number 10, you have the holiday for the Hari Raya. Okay, Hari Raya break after the week number 10. So before the Hari Raya break, because Hari Raya, we take a long break. So I think if you have a test after the Hari Raya, everything forgotten. So we make sure everything is fresh. We do the test before the break. So maybe the test would be in week number 9 or week number 10, just before the break. So to give you an idea of where the test will be. Okay. All right. So I'll see you again. Have a nice weekend. All right. Tuesday next week, inshallah, we have Ramadan. But we may have the class on Monday. So the Monday we have a class. All right. If I don't have a class on Monday, I will put a notice in the WhatsApp. But I think as of now, we will have a class on Monday. Okay. All right. So, but the quiz is confirmed. Okay. Quiz is confirmed on Wednesday. So I will see you again. Have a nice weekend. Take care of yourself. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
All
Thank
right.
you, sir. Thank you.
Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.